All right, so if you're watching this video right here, it's probably because you need to complete some part of this packet. This is statistics, chapter 2. We call this packet numbers. So just real quick, this packet's a little different. As you can tell, each section tells you how many points um, you will receive for completing each section. So please pay attention to that. Each page is worth 10, 10 points. Front and back is 20. There's 5 pages. 20 times 5 is 100. So each packet is worth 100 points. Um, we are going to go ahead and just get started. So get your pencil out or your pen and make sure you put your name. Make sure you tell me what period you're in. But the first thing that we're going to talk about in terms of digits and numbers is that there are numbers that have no base, and then there are numbers that have bases. Okay? Now we're going to start off first with numbers that have no base, such as what people started doing a long, long time ago, about 6,000 years ago. They just started doing tallies to count. Okay? This meant 1, this meant 2, this meant 3, and so on and so on. But the problem with that is that what happens if you want to write a really big number? Are you going to start tallying up, like if you want, say, 700 tallies? That's a little bit too much. And it's going to take a long time for you to read it. So 700 over here on the bases, boom, just like that, super quick. On this side, if I wanted to replicate 700, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is gonna take a long, long time. So we don't really use no bases anymore, unless if you guys are tallying something like at the beach and you're writing on the sand or like on a stick. But for the most part, I want you to understand that numbers in mathematics are technology. And a lot of people don't consider it technology, but think of it kind of like the wheel. And it just so happens to be that the wheel was invented about 6,000 years ago. Numbers were used, like our numbers were started to use like about 6,000 years ago. So it happened around the same time. But a wheel is part of a car. It's part of a car. It's part of a bicycle. It's not the, like, say, the main invention, but it's used on a lot of things. And even like in watches, it evolved into like a gear. And so it's used in a lot of technology. And that's how mathematics is too. So math is used in everything, in all the technology, on, the computers, your cell phones, microphones. Everything basically uses mathematics. And that's one of the reasons why I tell all my students, like, you have to change the way that you see mathematics. You can't think the way that people used to think in the old days. And I'm saying old days are like yesterday. Yesterday is when people used to say, I'm not good at math. I suck at math. I hate math. You can't do that anymore. It's like saying, oh, I don't like to speak. I don't like to talk. You have to speak. You have to talk. You have to do math. You have to change the way that you think. And then again, in this channel, I'm really calling it Best Math Teacher. But the truth is, I'm not your best math teacher. It's you. You're your best math teacher. You have to tell yourself that you can do this and you can understand this. So the first thing I want you guys to understand in this first section is mathematics is technology. You're going to be using it. If you're not good at it, you're going to be embarrassed in a couple years from now when you have kids or your kids have kids, and you're not going to understand basic stuff, because math is actually super simple, and that's my job to make it easy for you. But let's go back to this. So um, most numbers start off with no base, and one of those examples is the Roman numeral system. And if we go over here, we got some of the Roman letters. And 1 was written in that format as an I. 5 was V. X was 10. L was 50. C was 100, or is 100. D is 500. And then M is 1,000. Now just notice that this kind of goes like back and forth, like 1, 5, 1, 5, 1, 5, 1. Okay. And if we wanted to write a couple numbers, such as, let's just say, if I wanted to write the number, let's go with 24. Okay. Here's some of the problems with Roman numerals and numbers that had no base. Roman numerals, I would say, are like kind of like in between no base and a base. They're like the next level up to the tallies. But if you want to write 24, you have to write 10 twice. 10 plus 10 is 20. So I write XX. And then you don't actually write 4 tallies. You don't do 1, 2, 3, 4 for 24. What was funny is if you wanted to show 4, you would actually do some math and you would write 1V. 1V really meant 1 minus 5, which is kind of backwards to the way that we think, but that's equal to 4, so I'm going to write 1V. Okay, so this is, in my opinion, a little confusing, but if you ever see a smaller number in front of the bigger number, that means that you're going to subtract. So 1V means subtract. If I do a C and then a D, CD is actually 100 minus 500, so that gives us 400. Let me give you another example. So 1989. If I want to write 1989, I'm going to write 1,000, which is M. Then I'm going to write 900. 900, I'm not going to write 500 and then 4 C's, okay? You're actually going to write 1,000 minus 100. So I'm going to write 100 minus 1,000. So this is 1,000 and then this is 900 right here. 100 minus 1,000 is 900. And then if I want to write 80, I'm going to write L for 50. 50 plus 10, 10, 10 3 times. So X, 1, 2, 3. So this is 1,980. And then I'm going to write 9. And again, 9 is 1 minus 10. We're not going to do 4 in a row. So 9 is actually 1 minus 10. So I'm going to write IX. Okay? So that's 1,989. That's how you write it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 different letters for this. Okay? 9 letters. And if I want to write, say, 2007, this is 2000 is easy. It's just 2 M's. M, M. And then 7 is just 5 plus 2, so V11. And so this is 2007 and it's just 5 characters. So that's a little weird. That's different than us. 5 letters or 5 characters for 2007. It's a little confusing, but it's fun. I'm not gonna lie. It's fun, but you have to do math and it takes work and it's not so easy for you to like identify the numbers right away. So if you were to write like say 875, boom, look at how fast we wrote 875. Convert that into the numerals. It's gonna take you some thinking and some time. So remember, numbers are technology, and technology keeps getting better over time. So the no base is like old tech. Bases are the new tech. Now let me explain what bases are. Bases are kind of like our time. This is the one that makes the most sense for me, okay? We do 1 second, 2 seconds, 3 seconds, and it goes all the way up to 59 seconds. And then it resets at 1 minute, okay? And so see how it changes, and then it starts back up and it goes 1 minute and 1, 1 minute and 2, so 1 minute and 1, and so on and so on. But basically there's a reset. Our time uses a base 60 because the Babylonians used base 60, and they're the ones that basically started measuring time. And so we went off of their style. That's why we have 60 seconds in a minute, which is why we have 60 minutes in an hour, and so on. But in terms of our number system, we use base 10. So every 10 it resets. So when it gets filled up, it then goes on to the next. I'll explain it over here. So the ones, we start off with the ones. it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then once it gets to 9, it resets back down to 0. And then it moves on the next tally to the tens. And so it keeps doing that until this one gets full, and then it moves on to the next one. And then when this one gets full, then it goes on to the next one, and so on and so on. But let's write down the numbers. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's kind of funny, but 9 is the biggest one-digit number, okay? And once you get to 9, it goes back down to 0, and then it starts the reset. Okay, kind of like our seconds in our time. They reset, and then it moves on to the next one. Okay, so this is 0. Go ahead and write down all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is interesting. We have 10 digits, and we also have 10 fingers, and our fingers are also called digits. So I think that's probably why we picked 10 digits, but ironically, I think it's the most advanced system. It depends who you talk to. If you talk to somebody that works with computers, they might tell you that base 16 is the best, but because they go off of 16 bits and they go off of those multiples, but it just depends. I actually think this is the neatest and nicest way. We can also calculate percents very easily. So that's another thing. Let's go ahead and write some numbers right here. I've been telling my students lately just to write 9, 9, 9 all the way across. Now, what does this number read? 9,999,999.99. It's almost 10 million, okay? So if this one was to go to the next one, like if we got one more penny, that would then make this one go up, up, and basically when it goes up, it's gonna turn to 0, 0, 0, 0, 0, 0, 0, 0. Okay, so these cancel out, cancel out, cancel out, cancel out, cancel out. And then this one turns to 0, and then we would then add another 1 over here. And so this would really read 10 million. So anyways, why am I having you guys write 10 million? Because I've been telling my students that that's how much money you should aim for to earning. You don't necessarily need 10 million. Right now in our time, I think 2 million is enough. But the way that money is depreciating, 2 million is not going to be worth 2 million. 2 million is going to be worth $1 million, and then eventually it's going to be worth less and less and less. When I first started working in high school, and I used to work in the fields, just so you guys have an idea of how much I was earning $5.75 an hour. Minimum wage right now is 3 times that amount. And that's only within, I started working in the fields when I was like 15, so I'm like 30, so that's 15 years later. So in 15 years from now, who knows? If minimum wages, like I heard right now, like restaurants and businesses with like X amount of employees have to pay them at least $20. If you increase that times 3, that means that in 15 years, minimum wage might be $60. Okay, so I don't really know what you should aim, what's gonna be the real number, but I'm telling everybody to aim for $10 million because you can live off of $10 million, meaning you can live off the interest, or you can buy some apartments and live off of the rent from those apartments. $10 million, you'd be good. And that's why I keep telling everybody, you gotta start sooner than later. Now, down here, I want you to write 1,000, then write 1,000,000, 1,000,000,000, and 1,000,000,000,000. So why is 1,000 times bigger? So I wrote 1,000. So why is it 1,000 times bigger? So every time you go from one of these over, that's times 10 times 10 times 10, okay? And then if you move over 2, it's not times 20. It's now times 10 times 10. So what's 10 times 10? 100. So if you move over 2, that's that's 100. But remember, we're trying to go from 1,000 to a million. That goes over 1, 2, 3. So you multiply 10 3 times. 10 times 10 is 100. Times 10 is 1,000. So from 1,000 to a million, that's 1,000 times bigger. From here to here, that's 1,000. And then from here to here, that's also 1,000. So let me explain. If you have a person who is a millionaire, okay, so I'll draw a girl, and we have another guy over here, so another person, and he only has $1,000. How much more money does she have than this person? 1,000 times. She's worth 1,000 of him. And then it goes the same way over here. So if we have a billionaire, how much is a billionaire worth? He is 1,000 of her. Literally $1,000 million. What about a trillionaire? So a trillionaire is 1,000 billionaires, and that's why it's so hard for us to have trillionaire, excuse me, because, and actually I don't think we have a trillionaire just yet in our timeline, not yet, but that's 1,000 billionaires. We already don't have that many billionaires, so imagine 1,000 of this is worth that. The other thing that I want you guys to understand is how much bigger is a trillion than a million? From here to there, it's 1,000 times 1,000. It's 1,000,000 times bigger. So how do we compare her to her? She is a million millionaires. That's a big difference from here to there. And so I don't want you to get tricked like how Americans got tricked back in 2007 in the recession, where we bailed out the banks and basically gave them $1 trillion, and then the banks came back and gave us like $1 billion back. The numbers are a little, a little different. It's not exactly it wasn't a whole trillion. It was like a couple trillion, and it wasn't a billion. It was a couple billion. I think it was like 90 billion. But point of the story, it's like this. It's like if you let me borrow money, and I ask for $1,000, and then later on I say, hey, here's $1 back. Thank you. And you're going to be looking at me all weird like, wait, I gave you $1,000. And I'm like, yeah, I gave you $1 back. You're like, no, I let you borrow $1,000. That's a big difference. So that's basically what happened. It's not the same values. And everybody was okay with this. And the reason they were okay with this is because most Americans don't know the difference between a million, a billion, and a trillion. You have to understand that there's significant increases from a million to a billion. It's 1,000 times greater. And then from a million to a trillion, it's 1,000,000 times bigger. And the reason most people think it's the same thing is because to them, they're like, oh my God, $1 million is a lot. Oh my God, $1 billion is a lot. Oh my God, $1 trillion is a lot. Yes, it's a lot of money, but they're significantly different sizes. So now let's go to the back side. So I have my students, write down as many things as you can think of. And I give you 2 points for each line, or 1 point per line. So this is 2 points. So try to fill it out all the way through. We can write bananas, cars, houses, pencils, etc., etc. I'm not going to fill it out. That's your job. But why am I having you write this down? I'm having you write this down because the truth is, that's what math is. It's actual stuff. It's not like doing these examples. Yeah, this is math, but it's not the real math. Real math is when you have to calculate like how many bananas you need for your smoothies, or how many cars can fit in a parking lot because you're having a party, or I don't know, in terms of houses, how many houses should you own so you can live off of like the Airbnb rentals and all that stuff, okay? That's real math. This is practice, okay? This is like if you're practicing for a basketball game, like it's practice. The real game is on Friday nights when there's refs and you guys are wearing your jerseys. So right now, I just want you guys to just add these. 1 plus 9 is 10. 2 plus 8 is 10. 3 plus 7 is 10. These, I have a lot of simple stuff, and you might say, why are these all 10? Because I want you to see a pattern. Anytime you see these two numbers, that's 10. Anytime you see these numbers, 10. Okay? These are things that you guys should know. And then what happens if you add the number the same number twice? You should know these two. So go ahead and practice. And then I'm going to go ahead and do one example over here. This is where the bulk of the credit is, because I give you guys 8 points. And so I do 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to pick let's pick this one right here. So let's do this. When you add in this version, you're going to add the ones first, then the tens, then the hundreds, then the thousands. And in this case, 8 plus 4 is 12. You're not going to write the 1 down here. You're going to write it on the top, because you still need to add some more. So 0 plus 8 plus 1 is 9. 1 plus 5 is 6. And then 7, that's going to stay like that. So that's our answer, 7,692. Okay? That's it for this one. Go ahead and practice it. If you guys need help, I can help you guys out. But you do have a Delta Math assignment in terms of adding positives. So you guys need to go ahead and log into your Delta Math assignment. Moving on over to part 2 in this chapter. Our blank is negatives. A negative number is equal to a real number that is less than 0. Numbers are classified into different categories based on their properties and relationships with 0. So these are the positive numbers. These are the negative numbers. And I think that positives are on the right-hand side because most people are right-handed. But if most people were left-handed, we might say that this is positive. Just something for you to think about. And most people think that positives are good and negatives are bad, but that's not always the case. There are some things that you might think are negative, but other people think are positive. And I'll give you an example in just a bit. Also, I want you to know this, that every experience in your life, whether you think it's good or bad, there's always something good in it. Okay, even when I got in an accident, and obviously it was bad, we had to contact the insurance, and it ruined my day or whatever. But to me, I took out some positives in that my parents came, my friends were supportive, I was fine, I was healthy, nobody was injured. So you always have to be able to find something positive, like from every single situation. So all I'm saying is everything is both positive and negative. That's all I'm saying. Now in part A, I want you to come up with some opposites. That's really what this means. These are opposites, okay? In physics, there's a law of polarity, meaning that everything has two opposites. Okay, some people might say male and female energy, those are opposites, but we're not going to use that example right now. We're just going to, I want you to come up with some examples, and I want you to tell me some go on one side and some go on the other side. I might choose light and darkness. Now, some of you guys might say, oh, I like the darkness, Mr. Martinez. I don't like it when it's light. Well, remember, nothing's really good or bad. They're just opposites. Kind of like hot and cold. You might say cold is better, Mr. Martinez. Well, it's an opinion. So come up with a couple of these. You need to have at least 4 so you can get your four full points. Going now to part B. This is how we subtract. If the number on the left is bigger than the number on the right, it's gonna stay positive. Okay, it's gonna be positive. So 10 minus 9, 1. 10 minus 8, 2. 10 minus 7, 3. And so I'm doing this so you can see a pattern. But go ahead and finish this. Go to the back side. And then I want you to come up with some bad habits and some good habits. bad and good. Why am I having you do this? And we're gonna write a line here, okay? But let's say a bad habit. My bad habit is I go to bed late. And just be honest with yourself. But my good habit is I brush my teeth. Before going to bed. Or going to bed. So I guess there's always something good, right? But what I want you guys to write is that getting rid of something bad is good. Why am I having you guys write this down? Because anytime you have a minus and they're next to each other, this is really actually positive. Okay? Now, I'll explain that in just a bit. But if we have a number smaller than the one that we're subtracting, that's always going to yield a negative. So 1 minus 9, negative 8. 2 minus 8, negative 6. 3 minus 7, negative 4. 4 minus 6, negative 2. And kind of like the Romans, who cares about the order? You can just say, okay, what's 9 minus 1? That's 8. But because this one's smaller on the left, then you just got to remember that it's negative. But here's what I'm talking about. Getting rid of something good is bad. If you have a minus and they're next to each other, this turns to plus. 5 plus 5. So 5 minus a negative 5 is 5. Oh, excuse me. 10. Okay, sorry about that. 1 minus a negative 3, minus, that's like saying 1 plus 3. So that's 4. Now be careful. If you have a negative and you add another negative, that just means you have bad and then more bad. And if you put them together, then you have more bad. So this is negative 5. But on here, we go back again. Minus is positive. So what is this minus, getting rid of something good is bad? So my bad habit is going to bed late. If I get rid of this habit, this is a good thing. Meaning I'm going to be going to bed early. So that's good. I am going to have you guys do some more examples over here. Let's see, where are we? Let's pick an example. Which one should we do? Let's do this one. Okay. So 1,324 minus 507. If we subtract the 7 with the 4, because we go with tens first, you realize that, hey, this is going to be a minus 3, negative 3. But you can't have a negative 3 on the tens. So what you got to do is you have to borrow from the tens, and that becomes a 1, and then this becomes 14. So then now you can do 7 minus 14 is 7, and then 0 minus 1 is 1. 5 minus 3, you can't do it, so you would have to borrow, but no need to borrow because there's nothing else over here. So you can just say 5 minus 13, and 5 minus 13 is 8. Okay? So there you have it. This is the example. I'm going to have you guys do the rest on your own. Do these. Should be easy. We're going to move on to the next section real quick. I just need a stretch. So I created this multiplication table. So let's check it out. It's a little bit different than most of the ones that you've seen. Most of the time you see them in a square. But the reason I did this is because I want you to notice that multiplication means growth. Multiplication can also be division. So if it can also go the other way, and it could be decay, meaning it gets smaller. But I want you to think as multiplication as growth. There's two types of people, okay? There is people that take advice from other adults and they go in a positive direction. And if you don't take advice from adults, you're going to go into a negative direction. So you have to be very careful, like going to college, not going to college, starting a business, being an employee, um, making good relationships with people, talking bad about people behind their back. So it's all this stuff. What I'm trying to say is it multiplies and gets bigger over time. So you have to be careful with your habits. 12 times 12 is 144. That's a much bigger number than if I say what's 2 times 2 is just 4. I am going to have you guys fill all the entire multiplication table. I'm not going to do it right now. But what I'm trying to show you is that things start to stack up. In the beginning, it might not seem like a big deal. The numbers are kind of small, like 1, 2, 3. 3 times 2 is 6. 3 times 3 is 9. Like these numbers look small, but they start to stack up on top of each other and they start getting big really, really fast. So I don't know, you can think of it as after 12 months or 12 years or whatever, but if you start saving up money, it's just going to start growing and growing and growing and get bigger. So you have to be very careful on all the choices you make every single day because your life is mathematics. And in the long run, it's going to show up. So let's talk about some of the rules in multiplying. These are just rules that we've decided as a society. I'm not saying they're right. I'm also not saying they're wrong. This is just what we teach in school. There are some people who question, like how were these rules created, but they seem to work for us. I do think that if we're going to evolve to the next level of higher consciousness and growing to become like the best versions of ourselves, we're going to have to think of this math as just one type of math and there being many types of math. So I'm challenging you guys to learn more math and think outside the box. That's all I'm saying. So the first rule is everything or any number times 0 equals 0. Okay, and I should have said any number. Anything times 0 is 0. So that means that if you're not starting, if you haven't started doing like your savings or thinking about college or going to school, you're at 0. So you got to start at some point. So that goes on to the next rule. Any number times 1 equals itself. Okay? So that to me just means you just got to start. There's got to be a 1. That day that you decide you're going to start working, that day you decide you're going to start brushing your teeth, that day that you decide whatever it is, but you got to start. Okay? Now the next one is a positive times a positive equals a positive. Easy. Now a negative times a negative equals a positive. And then, so basically the way I tell my students is like, look, if you're good and you do work with someone else that's good, that's good. If you're bad and you do work with someone else that's also bad and they try to like mess each other up, that's a good thing because that's two people getting what they deserve. But if you are good, a positive times a negative, that's bad. That's negative. Okay? And order doesn't matter in multiplication. So let's write that down. Order doesn't matter. So it doesn't matter if you're the one that's good or you're the one that's bad, even though I think all of you guys are good. because in this situation, this guy is gonna get the bad end of the the deal, and this guy's also gonna get a bad end of the deal because he's not gonna want to do work with him anymore, and he might start telling other people that he's bad, and so more people aren't gonna want to be doing good work with him. So that's just kind of like the way that I see it. But let's turn the page over. So using your rules, I want you guys to multiply. Remember, a negative times a negative is positive. Positive times a positive is positive. But then if you have just one negative, then that becomes negative. So just be careful with these. You have to do a good job of figuring out which ones are positive and which ones are negative. Just like I told you guys in class, you have to be careful with who you associate yourself, because some of you guys aren't very good at labeling people as good or bad. And some of you guys label good people as bad. Like you label people that are really good for you, like say some of your teachers, and you're like, oh my God, I hate Mr. or Mrs. X, but really they're there to help you out. And then some of you guys have friends that are not good for you, but you call them your homies and your friends. That's not good. You have to be able to identify what's positive and what's negative. And it's the same thing with the math here. Like, you have to be able to label this stuff down. Don't make that mistake of saying negative 3 times 7 is 21. You're going too fast. You're like, oh, 3 times 7 is 21. Yeah, but remember, there's a negative, so you have to make sure you carry that negative over. Don't lose track of who's good in your life and who's bad in your life. And don't be hard on yourself too, because the older you get, the more better choices you're going to make in life. Okay? Now, in terms of multiplying numbers that aren't just like single digits, let's go ahead and do let's do this example. Just because there are positives and positives. Remember, negative is going to be positive, but this one is going to be a negative, so just be careful with that. 2 times 4 is 8. And then, so you're just going to keep taking turns. Now, the next one is 2 times 2. That's 4. 2 times 9 is 18. But I'm not going to write the one right here on the bottom. It's like when we were adding, we're going to put it on the top. And then we're going to do 2 times 2 is 4 plus 1 is 5. Really, what that means is 2 times this number, 2,924, that's what that equals. Next, we're going to drop a 0 because this number 1 it's really 10. And then we're just going to do 1 times 4. This one's easy. So 4, 2, 9, 2. The next number, 3, that's really 300. So I have to put a 0, 0. And then 3 times 4 is 12. 3 times 2 is 6 plus 1 is 7. 3 times 9 is 27. So I have to put a 7 here, and then I'm going to cross this one out, and then a 2 there, because it was 27. And then the last one, 3 times 2 is 6. Okay? So, and excuse me, and I have to add that 2. So 3 times 2 is 6, plus 2 is really, this is 8. Okay? And then what we do is we add them all up. So really what we did is we broke this down into 3 problems. We did 2 times all of that, 10 times all of that, and then 300 times all of that is all of that. So then you add them all up. So then this is 8, 12, and then this is 10 plus 12 is 22, and then 7 plus 4 is 11. So this is my answer, 912,288. Okay, so there's my freebie one that I give you guys, but go ahead and work on the other ones on your own, and you can always double check it with the calculator. So if you just want to double check, hopefully I got this one right, because I didn't actually practice this one before doing this one. So let's see. Perfect. So 912,288. So perfect. You can always check your answers. I'm always okay with you guys using calculators. Let's go on to the next section. So this is day 4 now, Thursday, and we're talking about fractions. And one of the things that I told you guys when we were doing the warm-up is that I said that all of you guys deserve a piece of the pie, the big pie, the pie of wealth. There's so many houses, cars, so much money out there. You guys deserve a piece of that big pie. If we divided the earth evenly, everyone, I think I had calculated, don't quote me, but you can do it yourself or you can Google it. I think it's about 6 acres. Everybody's entitled to 6 acres. And obviously that's not true. Not everybody has 6 acres. Some people have a lot and most people don't have any. So I want you guys to make the good choices in life so that you guys can have as much as you can possibly own and have. All right. So let's look at this worksheet right here. I have it broken down in halves, thirds, fourths, fifths, sixths, sevenths, and eighths. And then you were supposed to have a ruler. So you should have a ruler. I passed one out. If you're at home, try to just find a straight edge. But the first thing I told my students is you're going to cut this in half. And then, because these are halves, so we cut them in half. And this one is just 1/2. This one is 2 halves. And so you're going to do this with all of these. If we go to thirds, so for thirds, I draw a straight line going down the middle. And then what I do is, it's kind of like a Y. So you're going to do a Y. Okay. I think this one, I made it kind of small. Notice that? This one did a little bit better, and then I got better on my third one. So the other thing about it is when you use fractions, they represent equal parts. So they all have to be the same. So 2/3, in this case, this is 2/3. All of them have to be the same. And that's what 2/3 looks like. This one over here is just 1/3. And then all of these are going to be filled out. Have to be all the same. Fourths, I'm going to put a ruler again because it's easy to just make a straight line. But this one you can just go like, I'm not obviously using a ruler, so I'm just doing my best. 1, 2, 3, and then this one's completely full. We're still going to write a little bit more, but we have to do this for the rest. So let's do fifths. Fifths, I like drawing a straight line on the top. Just the top. And we're going to try to do like a star. And I'm sorry that I'm going a little bit fast. I want you guys to take your time because the goal is to practice and make sure that they all look the same in terms of like the size. And I'm having fun with this. I hope you guys are too. So that's fifths. Sixth, we're going to draw a line straight down the middle. And then what we're going to do is we're going to draw an X. And again, if you go slower, I think you can do a better job. But you want to try to make all the pieces the same. That's the fun part of this assignment. Ooh, that one was not that good. But again, it's just practice. We're just practicing. And I'm going to shade 1. I'm going to shade 2. I'm going to shade 3, 4, 5, and all of them. Okay? Sevenths is really hard. I almost regret putting this on the paper. It's not easy. I'm just gonna say that. So let's try it anyways. I'm gonna put a line on the top on all of these. And the trick to this one is it's kind of like the fifths in that you're gonna have a small piece at the bottom. But then you gotta draw, let me see. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. So I'm gonna draw like 2 legs and then 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. 1, 2. 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. Oh, okay, this one's almost good. Again, it's not my favorite. The sevens are the hardest. Okay, so I'll cut you guys some slack if you cut me some slack too. But let's go ahead and fill these out. Oh, and I forgot to do this one. Okay. And then eights, definitely the easiest ones, or one of the easiest ones. Actually, halves would obviously be the easiest ones. But we go all the way down. And then we make a cross, like of their quarters. And then we're gonna draw an X. And remember, you're gonna try to cut them right down the middle. So I'm sorry if I'm going a little fast. Just trying to get done with this lesson, but it's been a long video. We're already at almost 50 minutes. So then just fill it out. So this is 3, this is 4, this is 5, 6, 7, and 8. Okay, so we're done right here. So let's go ahead and do one last thing where we're gonna write the actual fractions. We're not gonna write the fractions for the top because these are all equal to 1. But let's do this one. So this is 1/2, and 1/2 is equal to 0.5. What else is equal to 0.5? This one right here. This is 2 quarters. What else is equal to 0.5? 3 sixes and 4 eighths. Okay, so all 4 of these are the same. They're equal to just a half. On the thirds, we have 1/3 and 2/3. 2/3 is equal to 0.66 repeated. 1/3 is equal to 0.33 repeated. And this one's the same as this one right here, which is 4/6. And then this is the same thing as just 2/6. 1, 2, 2/6. Okay. Let me know if you have any questions. This is a lot to take in, but I'm sure you guys are following along. So fourths, we got 3/4, and then we got 1/4. This is 0.25. This is 1/2. We already said that, and then this is 0.75. Excuse me, 0.75. Which one's equal to 3/4? We gotta just kind of move around, but it's this one right here. It's 6 eighths. So that's the same thing as 0.75. And then 1/4, we're gonna have to move around again, is equal to this one, 2 eighths. That's equal to 0.25. Fifths is easy. 1/5 is equal to 0.2. This one's equal to 0.4. This is equal to 0.6. So let's put it at the top, 0.6. 3/5. And 4/5 is equal to 0.8. Why did I say it's easy? Because it just goes 2, 4, 6, 8. Okay? The 6 are a little bit harder. We already have 2 6. 2 6 is just 1/3. So that's equal to 0.33 repeated. This is equal to 1/2, and then this is equal to 0.66 repeated. So we just need to do this one and the one on the bottom. So the ones top and bottom. So the bottom one, just think about like half of 33. So that's 1 divided by 6 is like about 0.16. And I think it repeats, but I can always double check on a calculator. 1 divided by 6 is, yep, 0.1666. And then this one, 5 6 is equal to, I think it's like 80.833 repeats. Okay, so we got these down. That's us. I'm not gonna make you do the 7s, but we do have the 8s. So 7 8s. This is 5 8s, 3 8s, and then 1/8. So 1/8 is 0.125. We already got 2 8s. It's the same thing as a quarter. 3 8s is equal to 0.375. This is equal to 1/2. This is equal to 0.675. Or excuse me, 0.625. And then this last one, 7 8 is equal to 0.875. Okay. So anyways, I hope this was something different. I designed it myself, so I'm kind of proud of it, but I know it's a little confusing, but just look at it. Look at the whole thing, okay? It's all the fractions in decimal form, and it's only up to the 8s, but we could have kept going to the 9s, 10s, and so on and so on. This goes on forever and ever, so we're not, be thankful we're only doing a little piece. Last but not least, for these, I told all my students that were in class, just use a calculator. 2 divided by 7, 4 divided by 9, 2 divided by 6. You can get a calculator. Just do 2 divided by 7. That's equal to 0.285. Okay. These over here, I didn't tell my students to use a calculator. We did long division. But if you want to use a calculator, you can. So we did 8 divided by 3. You can't. So hopefully this is a refresher for you. But 8 divided by 30, we can. So 8 goes into 33 times because 8 times 3 is 24. We subtract, and that gives us 6. And then we drop the 9. How many times does 8 go into 69? 8 times. 8 times 8 is 64. And we're left with 5. So that's our remainder, and it's really and this is not a point. I'm sorry, that's just 38. I don't know why I did the point. Sorry. So it's 38 point something, and it's 5 divided by 8, and we already said that 5 divided by 8 in the front was 0.625. So this should be our answer. I'm hoping. If I get my calculator and I do 309 divided by 8, nice, 38.625, okay? Now, go ahead and finish the rest of this packet. You can watch this video as many times as you want. Just give it a like if you like the video. You don't have to. It's on my teacher channel. But I always appreciate it. I appreciate comments. I appreciate if you guys subscribe too. And if you share it, even better. But let me know if you guys have any questions. You guys can always email me. Hope you guys enjoyed this chapter. Can't wait to see you guys. All right, take care. Bye.